Anchor is a software platform that enables online file synchronization, sharing, and backup for businesses. A big focus is placed on security, reliability, integration, and control within Anchor. We provide IT professionals with the security and control that they need in order to manage a large-scale file sync and sharing solution. Simply put, Anchor is the most advanced file-based cloud sync platform for businesses. Architecturally speaking, there is a good way to look at the interactions within the Anchor system. You can think of them as being between servers and clients, where the server brokers the interactions between the numerous clients. The server handles all incoming and outgoing connections to and from the clients. And there are many different kinds of clients, including desktop and mobile. But they all serve the same unified purpose, and that is to help people access their files when they need it, where they need it, while not sacrificing security or IT control. And Anchor comes in many different flavors. You can host it yourself, we can host it for you, or you can host it on-prem for your customer. Regarding the technology, all of the dependencies and clients come packaged within one executable. So when you install the Anchor server, you don't have to worry about configuring a separate SQL database or an IIS or Apache server. We ship everything within our executable. The Anchor server and the desktop clients were built using C++, and this was done to make sure that we get the most performance we can out of the machine and to ensure that all of the functions are cross-platform compatible. The mobile clients are coded native to their operating system. So the Android application was coded in Java using the Android SDK, and the iOS application was coded using Objective-C. Web interactions are powered by an Apache web server that ships with the Anchor server executable. Company and user data is stored in a PostgreSQL database, which also ships with the Anchor server. The nice thing about using these two open source technologies is that they're highly documented, they're highly reliable, and they even give you some customization ability if you'd like to do a more advanced configuration or distributed deployment. Now let's take a look at the architecture, starting with a few key components. Here we have the Anchor server, the Apache web server, and the PostgreSQL database on the right side. Now the Anchor server you can think of as the hub. Before any files are stored or written to, they must go through the Anchor server. Any Anchor agents or clients, such as the mobile clients and the desktop clients, will send information directly to the Anchor server. Any web requests will go through the Apache server first, since the Apache server powers all of our web interactions, and pass those to the Anchor server as needed. Both the Anchor server and the Apache web server have access to the PostgreSQL database. In this top right corner, we have a few storage mechanisms. Let's talk about those. In Anchor, there are two primary stores. We have our file stores and we have our database stores. The file stores contain the compressed and encrypted raw binary data. The database stores contain many SQLite databases that contain file and folder metadata. Now, the reason that there are these two separation of stores is because when a file gets synced from a client, before it gets sent to the Anchor server, it becomes compressed and encrypted, and then it gets saved to the file store. Any metadata for that file, including file name, its folder, its file size, its last modified date, and its created date, all get written to a database store. The reason that we keep the raw binary data and the file metadata separate is so that we can scale these two stores very easily. You add a lot of storage behind your file stores, you don't need to add as much behind the database stores since it's just metadata. Also, for scalability reasons, the SQLite databases, having those separate is important because we can read a lot of information about the files without having to open each file individually to get that information. So keeping it separate makes a lot of sense for those reasons. And you can add more volumes or more storage to your file stores or to your database stores as you scale up, because we distribute the data evenly across any stores that you've specified. So if you start with a 1 terabyte drive and you fill that up to 750 gigs, all you need to do is add another terabyte drive, for example, And we will write to that other terabyte drive, the new terabyte drive, until it is about even with your first terabyte drive, and then we'll write evenly across both of them until they fill. So going back to the architectural overview, you can see how the storage comes into play. As a file gets sent from one of the Anchor agents or Anchor clients over the internet to the Anchor server, the raw binary data gets stored within the file stores, and the metadata gets stored in one of many SQLite databases. And from a high-level overview, there's one SQLite database per top-level folder. And we have three different kinds of top-level folders. We have personal user folders, which every user gets. We have team shares, which can be shared among users. And we have backups, which are also unique to users. So each of those types of folders gets their own SQLite database. Now let's consider load. In a lab, the server has been able to handle upwards of 5,000 simultaneous connected agents, each syncing files up and down. In most cases, even if you have thousands of agents deployed, you'll only have a subset of those that are actually syncing data. So in an aggressive scenario, you might have 5,000 all at once syncing up and down, and the Anchor server can handle this. We can also handle 1,200 simultaneous Apache web requests. That's web requests at one time, not within any given interval. That's all at once. So the servers scale up very nicely. On the agent side, there's really no logical limit to the number or size of files that can be backed up or synced by the Anchor agent. The file size and count limitations are really determined by the file system that you're using. Our Anchor agents will take data as they see it and will sync it up. And our Anchor agents sync up this data in an intelligent way. We use an rsync-derived algorithm that only sends and stores a file's deltas, or its changes. And these deltas are compressed and encrypted from revision to revision, and our algorithm basically detects byte-level changes and won't re-upload a file even if all of the data within the file has shifted as the result of a block being inserted at the beginning. Security is a core component of the Anchor platform. All data is encrypted on the agent as it is transferred to the server. Not only that, but you can remotely wipe Anchor data from machines that are connected to the Anchor server. No passwords or confidential information are ever stored in plain text. And if you host with us, know that our data centers are SSAE 16 and SAS 70 Type 2 compliant. We enforce password complexity requirements across the entire Anchor system, requiring a combination of symbols and uppercase and lowercase letters. As a last consideration, I'd like to talk about high availability. For partners planning on hosting their own Anchor platform, there are several configurations which support high availability. Out of the box, Anchor installs all dependencies on one machine and allows for the selection of your file stores and your DB stores. So these dependencies would include the Anchor server, the PostgreSQL server, and Apache. And then you would choose where you want to put your raw binary data or your file stores and your SQLite database or your DB stores. However, each of those first three components that I mentioned, the Anchor server, Apache, and the PostgreSQL, can be installed on separate machines and configured to ensure high availability. This is our high availability diagram, just to give you an example of how the configuration might occur. On the far left here, you have your Anchor server, and in the default installation, we'll install Postgres and Apache on the same machine. A simple high availability configuration allows you to spin up multiple Anchor servers, 2 or more, and only install the application server, so the Anchor application server, on these additional machines. So on one machine, you'd have the Anchor server, PostgreSQL, and Apache. And on the two other machines, for example, you would have just the Anchor server. You would put these behind a load balancer or a DNS server, and you would configure round-robin DNS or have your load balancer distribute the connections across the three machines. If either of these Anchor servers went down, you would still have active Anchor servers that can receive connections. These Anchor servers are aware of each other and share the same storage. The storage can be permanently mounted to one of these Anchor servers, and the other two can point to that storage as a UNC or CIFS path. Now, as an advanced configuration, you could also put the PostgreSQL server on a separate machine and the Apache server on a separate machine. Our documentation walks you through how to do this. Also, you can find documentation for PostgreSQL and Apache in case you would like to configure PostgreSQL in a synchronously replicated configuration or Apache in a cluster configuration. But to summarize, a high availability configuration starts with the load balancer at the front and then distributes the connection across two or more anchor servers. PostgreSQL and Apache can live on one of these anchor servers or can live on separate machines. All of the anchor application servers must be able to reach the same storage medium. That covers our architectural overview.